So let P of at some point on a graph of y equals x squared minus 8. This is hard to see. Y equals x squared minus 8. This says the point xy is a point on a graph. Express the distance d from our point to the origin of the function, to the origin as a function of the point's x coordinate. Well, let's pause that and think about it for a minute. Okay, we have a lot going on, and when there's a lot going on and you're not sure where to start, I'm going to say let's target some things. Let me grab a highlighter that seem to be important to us, or ring a bell. So distance, because we've been working with distance formula, that speaks to me. Another thing, first of all, I'm given this P right here, and they were to say it again here, so I'm thinking this is going to be fairly something important that I'm going to have to work with. Origin tells me that it's the order pair 0, 0, right? So I'm going to write that down in a minute. And I have this. Okay. I'm going to go ahead and start with the first thing that I came to, the distance, because we've just done some lesson on that, and a lesson on it, and I'm going to write the distance formula down and see if it helps me in any way to determine my next step. Okay, what we do know is for distance formula we need 2 points. Well, we determined that we have the origin, but we also remember that this is a point. Although we don't know what it is, we do know it's x comma y. So I know I have a point 0, 0, and I have a point x comma y. If I wanted to label this, it might help it since we're not dealing with all numbers. And let's take these two and plug them into this equation, this formula. Okay, so we plug in x2 minus x1. Then we plug in over here y2 minus y1. We simplify this, and we're down to the point where we're at square root of x squared plus y squared. That's as far as I can go with the information I've given. I've used this information, and I've used this information. What's the only piece of information we haven't used yet? This y equals. Well, if I know what y equals, does that help me out anything here? Yes, so let's substitute in, because we want this to be a function of the x coordinates. When it's a function of x, guess what? The only variable it can use in it is going to be all x values, all x variables. So the fact that this has a y in it, we don't like that. We want to be able to have all x variables. So here's our out. We see that y equals, in place of y, we're going to come down here and plug that in. Okay, so I make that substitution, and I get x squared minus 8 squared. So that's going to ask me to go off to the side and FOIL this out. So go do some scratch work over here, and then we're going to put our answer back and simplify. FOIL this out. Add like terms in the middle. I get x to the 4th minus 16x squared plus 64. I want to put that in place of just this portion. So I'm going to bring down my x squared. And then in place of all of this, I'm going to put x to the 4th minus 16x squared plus 64. Okay. Add any like terms that we have, and we have x to the 4th minus 15x squared plus 64. And let's make sure we're done. It says let P be a point, express the distance D, right here, as a function of the point's x coordinates. Here's distance D, everything in terms of x values, check. Okay, we come to our last problem for this. Express the area of the figure as a function of one of the dimensions of x. So, of one of its dimensions of x. Area of this entire figure. Write the function's equation as a polynomial in standard form. Alright, first of all, It's hard to see here that it's different colors. So let's call this the blue one. Let's make this one a red. And we'll let the other one be black. Okay. I'm also going to just call them A, region B, and region C here. Okay. We're going to just break this thing apart and do it in individual pieces. So let's look at piece A. Area, recall, area is what? For like this portion right here, area is going to be length times width or base times height. Let's just go with length times width. What about when you have a triangle? Area for a triangle, area is equal to half times length times width, or half of the base times the height. So we remember that from algebra. And I'm going to say area is equal to half times length times width. Okay, so what is or base times height is easier. So this is just going to be x times x minus 5. That's hard to see right there. This is x, and this is x minus 5. So we just say this side times this side, and we do half of it. So the area is equal to 1/2 x times x minus 5. Let's multiply that out. The area is equal to 1/2 x squared minus 5/2 x. Alright, moving to B. It's a triangle as well. So I'm going to remind myself that I'm using half times length times width, or the base times the height. This one is x plus 3 is right here, and this is x. So that would be 1/2 x times x plus 3. Multiply it out. A is going to be 1/2 x squared plus 3/2 x. C is just a rectangle, so area of a rectangle is going to be length times width. Which, alright, here, this one's easy. This part right here, this is x plus 2. I know it's hard to see, so that's going to be x plus 2. We need to determine this portion up here. So from here all the way across. Okay, so if this part from here to here is x minus 5, here to here is x minus 5, and here to here is x plus 3, what do we do with those two? Add them together, good. So x minus 5 plus x plus 3 would give us 2x minus 2. Good. So we had to calculate that side, but we just added this portion to this portion, and I'm going to erase it so maybe you can see that again. Okay, FOIL this out. First, outer, inner, last. You can pause it. Okay, when you FOIL this and simplify, you get 2x squared plus 2x minus 4. Now, it says write the area of the entire thing. So what do I need to do with each of these totals? Add them together. So if I add this one to this one to this one. Alright, here's my x squared terms right here. X squared, let me get a highlighter. So x squared, x squared, x squared. What's a half plus a half? 1. Plus 2 more. 3. So we get 3x squared. All right. The good thing about this is these two are common denominators. So when I'm adding the x terms, so a negative 5 over 2x plus 3 over 2x. It's just what? Negative 2 over 2x, and then that simplifies to just be, that's just negative 1x. Well, if this and this is negative 1x, and I add it to 2x, we just have positive x. So I've used this and I've used this. What do we have left? Minus 4. So we would say area as a function of x is equal to this polynomial.